Today we're doing, again, the first set of notes, and we're going to be on, this is the second day on this lesson. We're going to do the 4 examples that are directly below that chart that we just worked on filling out yesterday. Before we go much further, I do want to do a quick warm-up. So I would like you to write these 2 problems down and pause the video, and I would like you to just try these, and just try these on scrap paper, or I think you can flip your notes around. There should be a back page that's empty. Try these 2 problems on your own first, and then when you're ready and you have your 2 answers, hit play, and then I'm going to work through the solutions of these and see how you did. Alright, so to work through the solution, here I am dividing with the same base. So if I were to look at my chart, if I'm dividing with the same base, I have the same base of x, and I am subtracting my exponents. So my final answer would be x to the 5th power, and that's it. The next one, number 2, we are multiplying with the same base, and that's the very first rule. And the rule says if I am multiplying with the same base, that I add my exponents. So this is x to the 1/3 power plus 1/2 power. Now, I will have to do a little bit more work with this because I need to have common denominators in order to add them. So I will, between 3 and 2, the common denominator is 6. So I'm going to multiply this right-hand fraction by 3 and this left-hand fraction by 2. So now I'm at x to the 2, 6, plus 3, 6, which would be x to the 5, 6 power. Alright, so I hope you did okay with those. And again, like I said, we're going to move on and try the bottom examples at the page. So here's our first example, and again, like I said in yesterday's video, none of the rules apply when you are in radical form. So we need to get these out of radical form and put them into exponential form first. So the first thing I would do is say that this is x to the 1/4 power, because I know it's implied to be a 1 there, over x to the 2/8 power. And then I can do some reducing. So I'll have x to the 1/4 power divided by oh, sorry, hold on. Looks like I copied that problem wrong. That should be 3. Sorry. And then the 2/8 will reduce to the 1/4 power. And then when I subtract my exponents, because I'm dividing, I'll have x to the 3/4 minus 1/4. So this will be x to the 2/4, which again can reduce to be x to the 1/2 power. So if the direction's specified and I said leave it in exponential form, you are done. If I said leave it in radical form, you would say the square root of x. If I did not specify, you can decide which form you would want to leave it in, and either one would be correct. So either one of these answers is correct for this problem. Okay, so for the next one, we have the square root of y times the 4th root of y. And again, we need to get these in exponential form. So this is y to the 1/2 power times y to the 1/4 power. And again, in order to add these, we need common denominators. So I'll rewrite it first as saying y to the 1/2 plus 1/4. And common denominator between 2 and 4 would be 4. So I only have to multiply one fraction, and that's the 1/2 by 2. So this will become y to the 2/4 plus 1/4. So the final answer would be y to the 3/4. So if you want to leave it in exponential form, you're done. If you want to put it in radical form, you would say the 4th root of y cubed. And again, it just depends on what the directions specify or ask for, and if it doesn't specify, I would accept either. Letter C is 16 to the negative 2.5 power. So 3 things that you should notice are different: that my base is a number, not a variable. I have a negative exponent, And I don't have a fraction, it's a decimal. So I have a couple of things that are different here. First, we're going to apply the fact that it's a negative exponent. So I'm going to change this to say 1 over 16 to the 2.5 power. Next thing I need to address is the fact that it is a decimal, not a fraction. So I would want to think and say, okay, 2.5 comes from the fraction of 5 over 2. So I would change this to say 16 to the 5/2. And now I'm going to put it in radical form so I can simplify this further. So this is the square root of 16 to the 5th power. And now you can kind of go two ways about evaluating this. I can either raise 16 to the 5th power and take the square root of it, or I can take the square root of 16, get that answer, and raise it to the 5th power. So the order does not really matter in which you go about this. So I'm going to square root the 16 because that's a little bit easier to do in my head. So the square root of 16 is 4. I just still have to raise that to the 5th power. So the final answer is 1 over 1024. Now let's say you try to do this, and when you try to take the square root of 16, so like let's say it was a 15 there, and I try to take the square root of 15, and I get a decimal. Well, then you can't go any further. And this step right here would be your final answer if you couldn't take the square root of that value. So in this event I could, so that's why this is my final answer, because I could go further. Alright, so one more example. And it's kind of the similar effect to the one we just did. So here I have a negative 32 to the 4/5. Notice the placement of the negative is with the base. So a lot of students will say that this is 1 over 32 to the 4/5 power, which is not true. That only works if the exponent is negative, which is not the case here. My base is what is negative. So all I can really do is put this right into radical form. So I have the 5th root of a negative 32 raised to the 4th power. So I will show you how to do this with a calculator, but in the event that you don't have a calculator, you can just kind of take a moment and think. So the 5th root of negative 32, so I would think, okay, what could I multiply together 5 times? What same value could I multiply together 5 times and get negative 32? So that answer is going to be a negative 2. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. So the result of taking the 5th root of negative 32 is negative 2, but I still have to raise this to the 4th power, which would be a positive 16. And that's our final answer. So I would like you to try on the next page. There's 4 practice problems. All 4 are very similar to the 4 examples that I went through today. And then we will practice tomorrow.